let us look at the brief history of the feedback control theory. So the first feedback control theory example was identified dating back 3rd century BC in Greek, where there was a device, self-regulating flow device used in water clock. You know, water clocks are some of the oldest time measuring instruments. So this is one such water clock. We have a flow, that is a self-regulating flow device. This is the first device which I identified as a feedback control theory decision. So next example of a feedback control theory was also appeared in windmill designs used in Dutch around 15th century. You can see this windmill. So in the design of windmill, there was the concept called a feedback control theory. And also in 1788, James Watt developed the speed control device for his steam engine, which is called a flyball governor. You can see the flyball governor, the first flyball governor which is used here, and the principle is still used in a steam power plant for controlling the speed. So we can consider this is the first device which is used for speed control purpose, and which especially for feedback control theory. So next, the analytical tool for control problem was developed by Maxwell in 1868. So he used linear differential equation approach to derive the stability conditions. And later at 1876, Edward John Roth was able to determine the stability of higher order systems. Similarly, in 1895, Adolf Horwich developed the similar kind of solution, but he was unaware of the Roth's work. So in 1911, they combinedly developed the Roth-Horwich criteria, which is very important to find the stability of very higher order systems. During Second World War, typically 1900 to 1940, many developments took place in control theory. So an important military problem during this period was the control and the navigation of ships, which were becoming more advanced in their design. So among the first development was the design of sensors for the purpose of closed loop control. So in 1910, Sperry invented gyroscope, which is used in stabilization and steering of ships, later for the aircraft also. Minsky 1922 introduced the 3-term controller, which we usually called as a proportional plus integral plus derivative controller, PID controller for steering of ships. So this was the first controller used by the Minsky in 1922. Then the other developments happened during the World War because there was a problem. Main problem was the accurate position of the gun brought the moving ships as well as the moving aircraft. So this problem was addressed by Hayes in 1934 by introducing the servo mechanism to the world. So he is the first person who introduced servo mechanism, where we have the master-slave concept. The system has to follow the command signal generated by the other system or a computer. And to study the control and information processing problems invented by the radar radiation laboratory was established at MIT in 1940, and much of work in control theory during 1940 came out from this lab alone. And now frequency response methods by Nyquist in 1932 and also bode in 1940 have dominated the control systems since late 1940s as analysis and as well as design tools. And working at Northern American Aviation, W.R. Evans at 1948, he introduced a very powerful technique called root-locus techniques, which will give us directly, which is the direct way to determine the closed loop poles locations in S-plane. All these the developments which are the classical control theory developments which are applicable for single input and single output systems. Then people start thinking about the multi-input and multi-output systems. So those complex control systems emerged from late 1950 onwards. So the developments which have come till 1940, they are called classical control problems because we have textbooks which are coming, and they guarantee the solutions of such kind of control problems. And the further advances in control systems engineering resulted from space programs, associated challenges like launching, maneuverings, guiding, and as well as the tracking of space vehicles. Since about 1960, because the availability of a digital computer, a state variable theory, which is a part of the modern control theory, has been introduced by Kalman to cope up with the increased complexity of the modern plants. So during the years from 1960 to 1980, so we have advanced control concepts which arrived like optimal control theory and adaptive control theory and learning control of complex systems, which were fully investigated. And from 1908 onwards, maybe till date, we have the developments in modern control theory centered around robust control, H-infinity control, sliding mode control, and also some of the intelligent controls and associated topics.